Okay, so for this video, what I'm going to try to do is a lot of hands-on and cover some introduction to programming. I'm not a programmer by any stretch of the means or imagination, but I have picked up a few things over the past couple of years, all self-taught, and I just wanted to make this video as a way to make it easier for other people who are also not programmers to sort of get started and get sort of an entry level. And we're going to try to do so reasonably quickly. And I'm going to cover one program, but created with Java, Python, and JavaScript. It's basically the same concept of a simple converter program. And this simple converter program will show you how to take input. It'll show you how to put out output. It'll show you how to manipulate variables. My approach to programming, what I've sort of picked up and what I've noticed is that programming, when you really get down to it, is really all about tracking the variables. So here you can see we have this converter.java, we have a converter.js.html, and we have a converter Python. And the goal here, we can open up into the terminal. So the first two programs are very simple. They're just text-based programs. And if we look at the Java one, for example, you can write in Java converter. If you run that, it'll say, okay, so what do you want to convert? And you can pick T for temperature. Say, do you want to convert it from Celsius to Fahrenheit or Fahrenheit to Celsius? Let's say we're converting Celsius to Fahrenheit. Enter the temperature, and we say, okay, let's assume it's 25 degrees Celsius. What's that in Fahrenheit? And it'll give you the output. Similar thing, we have a converter Python, so we're going to run Python converter. You press a tab because you have the prefix of Python over here. It will automatically bring up this converter Python, and it'll create the same thing. So again, exact same output. Let's this time change miles to kilometers. So we'll put miles. Do you want to change it from miles to kilometers or kilometers to miles? We'll do kilometers to miles. So say we have 100 kilometers is equal to 62.5 miles. So these are sort of the text base. What's a little bit more interesting and what makes JavaScript and web-based programming so powerful is if we open this in HTML, open Firefox, new tab, switch over, load this up. You can have a similar thing, select, so we don't want pounds to kilograms, kilograms to pounds, say kilograms to pounds, and you'll, okay, well that's obvious. Pounds to kilograms. Oh, it's backwards. Sorry about that. We'll fix that as part of the lesson. So let's see how we get there. Since I noticed them, let's start with the Python programming. Python's an interesting language because Python itself can, it's a lot of people consider it to be a little bit more of an entry-level program. What you saw me do here in this terminal is you just typed in Python converter python.py. Python, the way it's structured in Linux is it compiles on the fly. Compiling is a process that most programs have to do in order to create an output. So just to sort of show you what I mean is, say I change this and then I recompile the original source code for this Java. That process right here, this Java C is the Java compiler using the OpenJava JDK environment. What it does is it takes this converter .java, which is actually the source code, so we can look at that real quick. See, we have the source code here, and we're going to go through this in a minute. But it takes this, which is human readable text, and it creates a class. And the class is the binary file. This is the file of the program which is written in something that computers understand, which I'm sure many of you have heard. Is all binary zeros and ones. There are millions of transistors and switches within any of these IC circuits, and they do very complicated instructions in order to process this and take your long stream of zeros and ones and make it into a readable output for you. And this all happens in a blink of an eye these days. But I don't want to get too much into the theory. One, because I won't really be able to talk to it in any stretch of the imagination, and two, the theory, I think, sometimes can be a little bit imposing to new programmers or new people learning the languages. And what I'm trying to do is just to try to get people started and make this accessible. So we're going to dive into the source code for these simple applications first, and we'll deal with a lot of the theories. But I did want to put out this concept of a compiler first. The compiler is what makes it happen automatically. Now, when I'm talking about Python, this is compiled like automatically within the Linux kernel, well, not within the kernel, within the Python application or the Python runtime that's inside of Linux. And what Python has is a very robust feature set. I find that it's very good for manipulating text, manipulating files, searching through files, finding information. Python gets used in a lot of things. Python is also becoming very popular these days because it's used for a lot of AI. Programs like TensorFlow from Google, they essentially take Python and they convert it into something which can run on GPUs, graphics cards, and make things work. And the Python are sort of the language of the day right at the moment for scripting any of these APIs, are these AI programming instructions. And the AIs essentially use what's in Python to work as like the parameters, or this is how I judge what's a good result and what's a bad result, and that's how machine learning happens. Java is used for a lot of web-based applications. It's also used, or at least it was used, for Android development, so for app development. Android has switched over to a new programming language called Kotlin. Kotlin is also a Java derivative, but it's streamlined a bit and getting more and more optimized for the Android programming stack. And then Javascript, like this, is for web design. And again, we'll fix this little bug in just a minute. So let's open up the Python file. We'll just go to a text editor. This is, if you were on Windows, you could do the exact same thing. You just need to install a Python on your Windows computer. Linux, it comes in by default. And if you don't know how to do that, you just search for Python. You can find the download Python, download.org. You can just download this for Linux or Mac OS or Windows. You can just download the instruction set. What I'm using is just a command line based version, so it's pre-installed and I don't need to download anything. So let's go over here. So let's look at the source code. So again, when I started off discussing programming, a lot of it, one of the big things, without getting too complicated, is knowing how to take variables, how to output the results of variables, and how to manipulate variables. And I think so long as you can keep track of where the variables are, the other semantics and all of this stuff over here really becomes quite trivial in a lot of ways. It just at this point it's just work to go through and find things. Now there's always going to be an art to programming, and I will say that these programs are some of the first programs that I ever wrote, so hopefully you'll see that actually as we go through these three examples, my programming has improved a little bit. And it's also, for sure there's many ways for people to write much better programs than what I have, but this gives you a good overview of what the syntax looks like. So in Python, it's pretty easy to get started. Here we're basically creating a variable. We're just saying this variable is going to be called choice. Now choice, you don't have to tell Python what kind of variable it is. You do in Java. So in Java, you have all of these variables that we need to get sorted out way in advance. Python is a little bit more fluid. That can sometimes have disadvantages, but for beginners, it makes it easier. So you basically just assign a variable. As soon as you write anything and assign this equal sign to it, it's a variable. So Python is looking at this and assuming this has been assigned a value, so it's now a variable within this program. Then we're calling this command called raw input. The raw input basically takes, whatever happens after you read this line in, it automatically takes that and assigns whatever I chose or whatever I typed into the terminal. Like when I chose here, I said M. Okay, so that was the miles to kilometers conversion. So it takes in the choice from what we just added here. We just asked for this. This is just text. You need to have the parentheses here. And then this text, this /n, this means new line. This is fairly common in actually a lot of programming languages, Java, Python, Bash scripting, anything, JavaScript also. A lot of programming languages, when you need to show different lines of text, you use this /n within parentheses. Okay, within these parentheses, and that /n gets read in by the program as a new line. Then we start going through and we do a whole bunch of if-else statements, or if-else-if. This is probably something that I'm sure many of you who've done like introduction to programming, you maybe already know, or even if you're very unfamiliar with programming, you may have heard that programming is a bunch of if-else statements, and if-else statements is what allows you to create things like an interface. It also allows the computer to adjust and modify based on input or based on variables, based on certain restrictions that you assign, what to do. So, for example, all we're doing here is, again, in this output program, we had the Python converter, Python Py. .py basically tells Python that this is a Python-based script or a Python-based program file, and you have the temperature, the pounds, the kilograms, inches, centimeters, etc. You have these 6 choices, and first we take the choice. We say, okay, now if the person chose a letter T, could have been a capital T or a lowercase t. So if choice, this is equals. You notice the two different differences here. A single equal sign basically means that we're assigning a variable. If I had wrote something like this, choice, or I should say if choice equals T, it wouldn't evaluate the statement. The double equal sign means that Python is going to evaluate. It's going to check if that is true. If we were just doing a single equal sign, like we did up here, what this is saying is that choice does equal this. You're basically telling the program, this is the new value of choice. If I had written something in the script, choice equals T, then this would always be true, because it would assign the input that I gave it, and then it would reapply this choice T, this value of T back to choice. So basically overwrite what we just wanted to get. So we're not going to do that. And then here is a little comment that I wrote to myself. This number symbol, or pound, is how you do comments in Python. This is just a little note to myself. And honestly, for more complicated coding, the more comments you have, the better. It sort of breaks up code and basically tells people what this stretch of code is maybe doing. If this was hundreds or thousands of lines long, then these comments really help, particularly if you want anyone else to look at your file, or if you haven't looked at it in a long time like I haven't for this. So once we take that, then we offer a second choice. Again, we say this is choice 2. This is the sub-choice of this initial choice. So we're saying, okay, which one do you want? Okay, you picked the miles to kilometers. So if we go down to say miles into kilometers, we picked M. We prompt the user again. We say there's second choice. We use the raw input command. We output this line of text. Now, if they choose miles to kilometers, say if this choice 2 is also miles, or m, also m, so they chose the miles to kilometers, then we have this, we collect the value for it. So this is step 3, please input your distance to kilometers. We ask for the input, collect it. What this is doing right here, this int, in programming that's called parse, we're parsing this variable. We're basically telling the program, we're telling Python that this input needs to be an integer file. Okay, so this int is telling Python that we need an integer file, and the reason I did this is because it was probably taking this in as a string. As soon as you do a string, you can't manipulate it. So I couldn't multiply it by 1.6, which is the conversion rate from miles to kilometers. There's 1.6 kilometers for every mile. So by getting this raw input and turning it into an integer, Python then knows, okay, I can actually do math with this now. So I can take whatever value that was inputted, in this case it was 100, and I can multiply by 1.6. So let's actually do that in the miles section. So we'll run this again, choose miles to kilometers, we'll do miles to kilometers, we're going to enter 60 miles, and the output is 96 kilometers. Okay? And then this is the mechanism for providing that result. We get this result, we then take the result and we parse it again. We turn the result from an integer and we turn it into a string, and then we print it, and we say print result plus kilometers. Now the reason I turned it back into a string is likely because I was having trouble with the output. For some reason Python wasn't liking my output. So we can test that to see what happens. Parsing variables with Python is one of the kind of annoying things about the Python programming language. See, in Java, we know what each variable is. We assigned it up front. Like this is a double, which is basically a number with decimal points. And we had that all listed up, straight up and up front. In Python, it can auto-assign, but you can always force it. And this is what these integers and strings values are doing. But let's see, if I take this away so that the result is not being turned into a string, sometimes the output may not be able to read the output or spit it out on the screen correctly, but we can try. So we'll save it. Okay, so we've saved it, we made a change. And again, this is all just a text file, so it's very easy. Anyone with a computer can get started writing up this language. And we'll run the program again. Again, we'll do miles to kilometers. We'll choose the miles conversion that we just did. So that was where we just made this change. I commented out this line of code. Enter my distance in miles. Say we'll do 100 miles. And you get this error. See? So the error was we cannot concatenate the string and float objects. So there's no way for the output to have both the integer here and this little a units measurement that I added to the end of it. So that's the reason why we first parsed it and turned it back into a string. Okay, and the rest of this code, that's basically it. It's very simple, and this is sort of an exercise that I do when I'm learning different programming languages. If I can write this program on different programming language, then I at least can get familiar with the syntax of each different programming language, and I can do, some of the basic variable tracking. I know how to get the input, I know how to produce the output, and I can sort of work through some errors like what this might have that comes up. So let's look at the same code again. This is all if something, and then this elif, this is else if. It basically means otherwise. You're saying, if the choice equals C, capital C or lowercase c, or if the choice equals F or F, and then it's just a long string of ifs and else ifs to get these variables and present which options then come next to the user, and how you manipulate the value of the options they provide. On Java, same thing. So Java requires a little bit more legwork, I guess. But when I first got into programming, I started at trying to learn how to do app development. So Java sort of came with the turf, and I found really quickly in app development I needed to learn Java. So I ended up starting with Java, then going to Python. So a little bit of a reverse. But in Java, they have this really cool tool called a scanner. So this is helpful when you're working in this kind of command environment. So again, we'll run the Java converter again. So what the scanner does is it basically is something that lets Java pull in the variables. It's basically saying, I'm watching you. I'm waiting for your input. And if we did say like a BMI calculator, you can enter your height, say I'm 180, and my weight, I ate a lot yesterday, so 74. And it gives me an output, which is my BMI is 22.84, so I'm normal weight. That's good. And this is sort of how we go about it. So in Java, when you create something, you basically need to assign a class name. The class name is what then gets produced once you compile the program. So we see it here in the document. The class converter is telling Java that, okay, we're going to have this big long program over here, and this program is all part of this class. Okay. Now Java, when they manipulate things and they take these variables, again, there's a lot more syntax work that goes into play, and I'm not going to cover everything in a great level of detail here, again, because I don't want to bore people to death. But I hope that you can take a look at this source code, and I'll publish this source code again on my blog as well, so you can sort of go through it at your own pace. But what you do typically is we get this public static void main string arguments. This is basically telling that in this main method, or this main function of the converter, we're going to be inputting a lot of string arguments, and these string arguments is what the scanner is looking for. Okay. And inside this, we have all of our variables up front. All of these variables I assigned a double, and the reason is because sometimes the output has decimal places. Otherwise, you could just say something like int, and that would work too, assuming in the conversion you're not going to run into anything with decimal places. So we're using this as double. Then I'm going to have sort of information which I'm going to spew out, and these are going to be strings. So these are just like words and statements. So you have a conclusion, you have a selection. So this might be my initial selection over here. Temp select, weight select, length select, distance select. These are all different variables which then come into this Java code. And again, this was probably one of the first input-output programs that I created, so the code might look a little rough for anyone who's a little bit more experienced. And then, so what we're going to do here is we say system.out.println. This basically is saying is I'm outputting this line, this statement, to the terminal. So system.out.println, this is what's giving us choose what to convert by typing the key in the brackets. Okay, so you have this line of statement, and again the /n, just like in Python, means new line. So we output the statement. In Java, you have to finish every line of code with a semicolon. And semicolons, when I was first attempting to learn programming in college, were my bane. It was the one thing that I knew I had to do. And so I was constantly on the lookout for semicolons. You don't have those in Python, which is good and bad. Then we have, we call the scanner. This is calling this Java util scanner. The scanner, we're going to have a variable for it. We're going to say this is going to be a mount. This is basically how I'm going to get my values from the input from the user. we say, okay, we're going to use this scanner system.in. Then we're going to take this amount, this variable, and we're going to assign it to select, and select is our string. So this is our first selection. This .next here is basically saying that we're taking from the scanner, we took whatever was the next input that was given into amount. So again, it's a lot more complicated than just doing something that says raw input. But that's part of the way Java was structured. Java is a little bit older, I believe, than Python. So it's some of the programming semantics and metrics are a little bit more step by step, I would say. You have to know a little bit more about what's going on in the system, but still very, very human readable. So you have this select amount.next. This is basically saying from the scan of whatever input was taken, I'm picking up this next variable. This was a comment of code that I was using, I think, for debugging. So it was, again, just printing out what this variable got assigned to so I could track what was happening. And in Java, the way you comment out something is with this double slash. In Python, again, it was a pound sign. In Java, it's this slash slash. This is to comment out one line of code. Slash star star would be to comment out, all code afterwards until you do star star slash. Again, these are just programming, semantics for the language. And then, okay, we're evaluating if select equals t. In Java, they have these kind of methods that get called in, and it's always, you take the variable dot, this kind of method that you want to do. So for an evaluation, you can write it like this. You can also sometimes in Java write equal like that, but that typically in Java I've found works better with numerals. Not always as well for strings. Using the equals method or function is a little bit easier for strings. So select.equals, and it could be a capital, it could be lowercase. So we have this or. These two straight lines on the keyboard. This is right above the return key on your keyboard. Symbolize or in Java. Then we again go through the flow. So we have system out.println. We're just printing the information back out to the system. This is just the way it's done if you're running a Java application in your terminal. So you just sort of get used to writing this again. In Python, remember, we had this raw input, and then we prompted for the input. Same thing, it's just there's a different way of calling these functions between the languages. So in Java, you have this raw input, and in Python, you have this raw input. In Java, you have the system.out.println. You prompt again. You get the next available unit that was inputted. This is now my temp selection. So again, I'm calling back the scanner. The scanner variable was already assigned, so we're still scanning. We're going to be scanning, the whole length of this for as long as this program is running. So this line, this variable, the scanner is still functioning. And this temp select is now getting the next variable that was inputted to it. So you got this amount next. So what was just inputted to the program, and it says, okay, now we have this temp select variable. So we chose to do a temperature conversion. We can show that here. T. We're going to convert from Fahrenheit to Celsius. And enter the temperature. Say it's 25 degrees Fahrenheit, almost minus 4 degrees Celsius. So what did it do? We took the variable, we pressed the F key for Fahrenheit. So it said, okay, else if temp select equals capital F or lowercase f, we selected the Fahrenheit to Celsius conversions. It says, please enter your temperature. Prompt the user again for that temperature. Then we do the conversion. So we do the temp, then we basically do an algebraic conversion. we said, okay, amount next double. What this is doing is we're calling back the scanner variable over here, and we know it's going to be a double. It could be, maybe you want to do 25.5 or something, but in order to give us a good range of what kind of numbers might be inputted, and also to make sure that when we divide by this 1.8 over here, it can actually handle the calculation. It's not going to do any weird rounding. So we're working on a double, and temp over here, this variable was first assigned up here, double temp. And temp, we're now saying, okay, the value of temp is going to be equal to this scanned in value from amount next double. This is the value that we're scanning at this point in the program. And then we're going to subtract 32 from it, and we're going to divide it by 1.8, which is the conversion for doing Fahrenheit into Celsius. And then we output it again. So again, system.out.println, the temperature is plus this temp, degrees Celsius. And notice that Java is somewhat more forgiving than what Python was. We had to parse the Python result back to a string when we did the print output. Java didn't care. It'll just output whatever you have. So if you have this concatenated, sorry, it's a little hard for me to say, concatenated together, where you have a little bit of text, which is a string, and then you have a number or a double, a number with decimals in the middle, or an integer here in the middle, and then you have this additional text, then it doesn't care. It just prints out whatever was inputted to it. And then notice in Java, when you're doing, say, this if and then the evaluation, we have to look at the syntax a little bit. So you have the brackets here. So you have lots of brackets, and you have there's probably a proper word for this. You use this kind of bracket for larger streams of text. So this is the way Java manages itself. This is the way that Java breaks down pieces of certain bits of code. So if this is true, this whole section of text, then do everything within this bracket. Okay, and these brackets have to align. Missing these brackets can really screw it up, and will often lead to errors. And that's why you end up having to do things like doing an extra println or some other type of output, so you can sort of see where the code's kind of breaking down. And that's sort of the way a lot of debugging happens. But even though it's very annoying trying to keep track of all these brackets, in some ways it's a little bit easier than Python, because Python doesn't have any brackets. Python, it evaluates everything based on the tabs. So I have 2 tabs. That means because this is tabbed 1 up, all the other sub-tabs are what gets evaluated. And that's easy from a convenience standpoint, and it's easy for readability. But if you screw up a tab, or you just have like some weird spacing thing in your text editor, sometimes the Python goes a little bit nutty. So I think there's advantages to having something which is clearly marked with brackets, so that you're not going to run into spacing issues. But again, it's just those are the sort of semantics between the two program files. Okay, so roughly, I mean, again, the whole rest of the program is all the same sort of steps. It's just else if else, or not if else, but if and else if, and running through all the various choices. Now there's an easier way to do this in Java. It's not available in Python. There's a method called a switch. So let me close this. Close without saving. Python doesn't have a switch per se, so everything has to be if and this sort of elif, or what is a shortened form of else if. But in Java and in JavaScript, which we're going to look at right now, JavaScript, we have the switch. And what a switch does is it's the better, more streamlined way of writing this type of program, where you're just basically asking for various kinds of input, and the input could be multiple different values. So by having a switch, you ask the question once, and then you can very easily have all these different cases, and it saves you from having to do if, else if, else if, else if, else if, else if, over and over again to reevaluate everything. You're basically just saying, okay, I have the switch. I could have multiple responses. If this, well, let's start from the beginning before I go too far into it. Sorry. So here what we have is we have a little bit of a UI. Now the UI itself is created with HTML. So this doc type is an HTML document. We have just a quick header. We got this JS script on top for jQuery that actually probably isn't even needed for the scope of what's actually being done. Just comment that out. Oh, it is commented out. I'm sorry. So this is actually commented out. But you can see here. This is how you do comments in HTML. You have this bracket, exclamation point, dash dash, and then that basically comments out this little piece of text. But we can delete that. And then we have this body over here. Inside the body, this is all HTML. So this is all sort of the UI elements. So we have this kind of conversion, and we have this select ID. This ID convert is what we're going to refer to later when we're trying to grab variables. Again, it's all about knowing where the variables are, knowing how to get the variables, and keeping track of what input is where. And that's how you build out programs. So we take this, we have one line, just select the type of conversion. Let's look at it over here. Select the type of conversion, click submit, conversion. What that looks like over here. We have this text over here, conversion, break. This is a line break. Select the ID. So this is the selection button. Let's see if both of them are wrong. Celsius to Fahrenheit, say Fahrenheit to Celsius, yeah, let's do 75. Submit. So that looks right. Let me save this just to make sure. Alright, save, submit. Yep, okay, still works. So far, so good. And we're giving this options. Now these options are what allow us to have the drop-down list. So option, select, option, you have this hidden value. This is what JavaScript will be able to read in, the actual value of the variable. This is the text which is actually shown to the user. So I could change it and say in full form, just pounds to kilograms. This again is still HTML. Save it, refresh. So we have this pounds to kilograms now. It should still be wrong. We haven't fixed the math part, but right. So it's doing the reverse calculation. But the value still works because we didn't change the actual value. This is the part that the programming actually looks at. This is just the external text, or the what's shown to the users. And then we go here. This is the little bit of the amount to convert. So all of this is the selection. Okay, from here to here. That's our drop-down menu. This is our input of the number over here. This is the input. So amount to convert, this is the text which is located here. And then this input basically gives us this little square bar so we can input some text. We input our number, and then at the bottom you click submit. On click submit, we do our convert function. Now this is where the JavaScript comes in. So you see this convert brackets that says we're going to call a function. And then we have this part. Now this heading here, script, is very important. That's where the HTML knows that, oh, we're calling in JavaScript now, so we're going to bring in this JavaScript function. And as soon as we get to the JavaScript part, you'll notice that we got these brackets over here again. We have variables. And then we have 3 variables. We have converts, result, amount. Converts is equal to this dot get element by ID. Now this is sort of an important function within JavaScript to grab the variable from somebody. Once you have this get element by ID convert, which is this ID converter, you're basically telling JavaScript, okay, I want you to go into the web page. I want you to look at the values which we assign here from this selection. Okay, so go look into the selection. Go look for this element ID, this converter, and whatever HTML element or whatever HTML section on the page has this ID converter over here. It happens to be a selection. Get me whatever the value is of this element at that time. So as soon as you select this, what we've done is we've taken this element ID and we've assigned it right now this FC variable. This FC value is now assigned to this element. And then once we call the JavaScript function, now we don't call until we do the submit. But once we do click submit, JavaScript grows, it fetches the value, which in this case would be the selection. And then we do the same thing for the amount. So we go get this amount. This amount over here is this input and the ID is amount. Okay, so we go get this field. I got this value from this field in this line of code. I got this value from this field, this input ID from this line of code. And then I want to evaluate it. So switch converts is I'm evaluating this value of this variable. So take this variable, put it in here, based on the value, if it's equal to pounds to kilograms, or if it's equal to kilograms to pounds, or if it's equal to F to C, or Fahrenheit to Celsius, or Celsius to Fahrenheit, then we evaluate and we do the math. So result multiply by 2.2, and this is where we're going to fix it. So we want to divide, right, because I had it backwards. And then kilograms to pounds, we multiply. Okay, and we'll save that. And then we produce the output. We say that document get element by ID, output inner HTML. We're basically taking the result over here and we're putting it within HTML. And we're giving it to this output. So this output is a paragraph that I have beneath everything over here in the HTML. So essentially what this is, if we look at this as a whole, and we can maybe do the inspect element in your browser, might help you see it a little bit better. But if we say, okay, we're looking over here, so this is the body. We're looking at the whole body of the HTML. Now we're showing, this is where the text is. Go down, we can see the select. So conversions over here, the selections over here. It shows you right there in the HTML, or in the browser, I should say. I'm sorry. And then we have all the different values that are available in these different options. Then we do the amount to convert. We get this input with this ID. And then we go down to output. Now output is idle, in the beginning. It was just assigned this variable here, and that's because of the JavaScript. If we refresh the page, all you have is this word output. It's just the default. It's waiting for something to do. Okay, currently it's output. And as soon as we run through this HTML, we'll assign the output. And so to wrap this up, let's just make sure that the conversions are now working. So we'll select pounds to kilograms. Say we want to do 160 pounds. Submit. 72. Okay, that's better. So now we have the function running correctly. .4, that's about right. 0.7, I believe. Yeah, there you go. And you can see what happens here in the results on the bottom. Okay. And again, all the brackets here need to be assigned like this. And then once you exit from HTML, you break out by using the script. You end your HTML section, you end the body, and you end HTML. And that's essentially it. So very simple programs. I'll put the source code onto the blog, and thank you all for your time, and I hope this was helpful just to get people started a little bit with some very, very basic programming. Again, I think you can do a lot once you know where the variables are, how to manipulate them, how to input them into the code, and turn them around, change them up, and then re-output them. So this is just a little exercise that I like to do when I'm learning a new programming language. So thank you all for your time.